and analysis of algorithms class. Today's lecture we are going to finish multi-threading matrix multiplication. So in previous class you have studied what are the basics involved in your multi-threading, and in today's lecture we are seeing one of the application on multi-threading algorithms, which is multi-threading matrix multiplication. So in today's lecture I am going to cover what is meant by multi-threading matrix multiplication followed by an example, and also coming to the objective. So after learning this lecture the students are able to understand the concept of multi-threading matrix multiplication, and whereas what is the basic difference between the block matrix multiplication, even this multi-threaded matrix multiplication. And next one is coming to outcome. So after learning this lecture the students are able to acquire the knowledge on multi-threading multiplication. So now coming to how to perform this multi-threaded matrix multiplication, right. So before going to that, I want to discuss you what is meant by block matrix multiplication, which you have already learned. So for suppose I have two matrices A1, A2, A3 and A4, here B1, B2, B3, B4. So here I am having two matrices AB and whose result is C, right. So in order to perform this matrix multiplication I require how many for loops? Here I am utilizing 3 for loops, right. I am utilizing 3 for loops, right. So here the overall time complexity you have already seen, which is big O of n cube, right. Big O of n cube is the overall time complexity to have the multiplication of two matrices, right. So now I want to decrease this time complexity with the help of multi-threading concept. With here I want to inculcate multi-threading within the matrix multiplication, so that I am going to achieve some decrease in the time complexity from the previous one, right. So now to accomplish this, here what I am going to do is to multiply two n by n matrices. To multiply two n by n matrices, we are performing 8 matrix multiplications. We are performing 8 matrix multiplications of order n by 2 into n by 2, and one addition. Also we are having 8 n by 2 here, 8 n by 2 into n by 2 matrices multiplications, and one addition which is of n by n matrix. So now we will see how to perform this. Okay. So let us consider this is your C matrix, C or resultant. Okay. So here A11, A12, A21, A22 into B11, B12, B21, B22, which is a two-dimensional matrix. Here two matrices I am having, right. In order to find C11, what I am supposed to do? A11 into B11 plus A12 into B21. Why? Because here a matrix row should be multiplied with a colon, right. So A11 into B11 plus A12 into B21, right. So here I want to reduce the time complexity. So how I am going to showcase you now? So here A11, B11, right. So this term I am taking it as C11, and here this term I am going to represent it as T11. T stands for temporary array. Temporary matrix. So here I am taking one temporary matrix. So here A11, B11 I am representing it as C11. Here this C is not this C. Okay, final C we will see once again. So here in order to make it into multi-threading, make it this matrix multiplication, to accomplish multi-threading, what we are performing is here I am taking this term as C11 and this term as T11, and this term as C12 and this term as T12, and in the same manner here I am taking A21, B11 as C21 and this is T21, and this is T22 and this is C22. Likewise I am taking each and individual term. So finally I will be having how many number of terms here? Here I will be having C11, C12, C21, C22 as well as T11, T12 and T21 and T22. So here I am having 8 terms I want to find out, right. So now we will see the process. So here before seeing the process, how we are accomplishing the recursion to measure this matrix multiplication. So here A11 into B11 is one of the term, A12 into B21 is one of the term, right. So likewise I am having the terms, 8 terms, the last term is A22 into B22, right. So here each term I am going to I'm going to divide into two terms, which is one is C and the other one is T. So here by taking those two terms, I'm rewriting the algorithm once again. So here this is a pseudo code for multi-threading matrix multiplication. So here I am having parameters, the three parameters which are C, A, B, N. N by N is a given order of the matrix. So now here if N is equal to 1, which is a smaller sub problem. So in that case directly I am giving the solution, which is C of 1 1 is equal to A of 1 1 plus B of 1 1. Else means I need to have some temporary matrix. As I said earlier, here the two terms I am dividing, one, the first term is C and the second term is T, right. So in order to find out the second term, here I am taking a temporary matrix. So in order to have the temporary matrix, I have to allocate the memory for the temporary matrix. So now after that I am partitioning A, B, C, T into n by 2 sub-matrices, n by 2 into n by 2 sub-matrices. So here matrix multiply C11, A11, B11, n by 2. So here if you have seen clearly, your first term C11, what is your first term? A11, B11, right? And your T11 is what? Here if you have seen A11, A12, A21, A22 into B11, B12, B21, B22, right? So here what is your first C1? C11 is A11 into B11, whereas T11 is equal to A12 into B21, right? So if you remember these two, then it is very easy for you to write the algorithm. So here C11 is nothing but A11 into B11, right? So here spawn matrix multiply C11, here I want to measure the C11. So C11, A11, B11. So A11 into B11 we will use C11. But here the matrix order I have changed to n by 2. Why? Because I am not taking the full matrix, right? Here I am taking only half. That is why here the size gets decreased to n by 2. So and also I am making this operation in parallel. Here in parallel this process will be executed. That is why here I have given spawn. So now here the next one, let us consider this one. So T11, A12, B21, right? So spawn matrix multiply T11, A12, B21, n by 2, right? So here spawn matrix multiply T11. So here to measure this T11, I am multiplying what? A12 into B21. In the same manner, here C12, in order to measure C12, what I am multiplying? A11 into B12. So A11, B12, n by 2, the size is decreased to n by 2. Now in the same manner, I am writing the matrix multiplication for the remaining terms also. So here for suppose T21, I want to get T21. T21 can be measured by multiplying A22 and B21. So that is why T21, A22, B21, right. So likewise I am writing all the 8 terms, and all these 8 terms are executing in parallel. That is why I have given spawn over there. Now finally after executing all these terms, finally the next step is to execute the addition process. Am I right or not? So here after measuring the C11 and T11, what I am supposed to do? I have to add this, right? I have to add this. So then only I will have the final result of C11, final result of capital C, right? So now matrix add C, T, n, because here whenever I am adding, the final result will be in n by n, right? So that is why here the order is n, C, T, n, matrix add. So now we will see how to add the C, T, right? This is a similar algorithm, addition of two matrices. So here if n is equal to 1, directly give the solution. Otherwise partition C and T into n by 2 and n by 2. Again n by 2 by n by 2. Again we are dividing, and here again in the same procedure, here spawn matrix add C11, T11, n by 2. again C12 T12 n by 2, again C21 T21 n by 2, C22 T22 n by 2. So here we are adding, we in order to get the first one which is C11, I have to add this C11 as well as T11, right. So here for that only add C11 T11 n by 2 and again C12 T12 n by 2 and finally sync, because here after all execution of all these parallel operations I have to get the final result, that is why sync. Okay. Now how to achieve this parallel sum? So here initially this is your matrix, okay, two matrices which we are going to multiply, right. So here I am having several terms over there, right, whenever we want to multiply. So which is A11 into B11, A12 into B21, right. So after getting these two terms I need to do what? Add. I need to add, then only I will have one term called C11, right. I will have one term called C11. So here multiply this one and add this one. So to make all these things I require log n time, whereas previously I require n cube, right. So now I want to represent with the help of a recurrence relation. Now previously you had already seen the recurrence relation for block matrix multiplication, which is 80 of n by 2 plus theta of log n. So by using master theorem you can solve this. So by using master theorem, if you are solving it, you will be getting the time complexity as theta of n cube, even you have seen already, right. So now if I want this multi-threaded time complexity, so whenever I am inculcating this multi-threading for measuring the matrix multiplication, so here 2t of n by 2. Why this 2t of n by 2? Because here each time we are dividing our matrices, okay, n by n matrices I am dividing into n by 2 into n by 2 and parallelly I am doing it, right. So parallelly I am doing it as n by 2 into n by 2 and n by 2 into n by 2. So here I am measuring this one and this one parallelly, right, for this. So that is the reason it is 2t of n by 2. If the given problem is small, so in that case directly I am returning the solution, that is your base case in your matrix multiply algorithm. So that is theta of 1. So together if I want to, okay, if I want to solve by using the Master's theorem, I am yielding theta of n. So whereas previously it is theta of n cube, now if I am doing in parallel the same matrix multiplication algorithm in parallel with the help of multi-threading concept, I am achieving the time complexity as theta of n. This is somewhat less compared to theta of n cube. Today we have seen what is meant by block matrix multiplication, and also you have seen multi-threaded matrix multiplication and how to achieve this multi-threaded matrix multiplication. Here 8 n by 2 into n by 2 matrix multiplications followed by 1 n by n addition, right. By making that we are achieving this multi-threading matrix multiplication. So here to achieve this multi-threading we are making the spawn, right. We are making each and every operation in the given multiplication as of spawn operation, and finally we are to get the result we are making into sync at last, right. And also we have seen the algorithm for matrix multiplication as well as for addition, because as it involves one addition in each and every term, right. To find each and every term there are 4 terms in C, right. So to find all these 4 terms we require 4 additions, right. So even for that also we have seen the algorithm, right. Thank you.